Okay, hello everyone. I hope you're all doing well and feeling energetic. Thank you so much for watching this video. In the past weeks, we learned about the basic of Python together. This week, we're going to dive into a much more important topic: conditional statements or if statements. At the end of this video, I'll give you a few exercises to practice as your homework. Please answer each question with detailed explanations, is important, and submit your answer on the courses system. Let's get started. Okay. Up to this point, we've learned how Python handle text, numbers, and basic operations. Now it's time to make our program think or making some decisions. In this section, we're going to explore conditional statement, which allow our code to choose different action based on certain condition. You can see this flowchart in this slide. Earlier, when we discussed flowchart, we saw that sometimes our program needs to take different actions based on certain condition. And conditional statements are exactly how we express those decision points in Python code. In other words, instead of the program always doing the same thing every time, we want it to respond differently depending on the situation, just like how we make decisions in our real life. For this, Python provides a straightforward and readable way to express these choices using the if, and else statements. Let's take a closer look at how they work, but first let me explain this. Okay, it's a flow chart. It's my decision making part. If this text expression is passed, I choose to perform this part of code, and else if means if this part of code fail, I want to do or to perform these statements. Okay, it's a flowchart that which we discussed about it earlier. Okay. In Python, an if statement is used to make decisions in our program. At the heart of every if statement is something called a condition. Here, age greater than or equal to 18, it's the condition. Okay. So, what is a condition? A condition is simply an expression that Python can evaluate as either true or false. So it has a Boolean value. Okay. For example, age greater than or equal to 18 here in this line of code is a condition. It's a condition. It's true if the age is greater than or equal to 18, and it's false if it's not. In this in this situation, this condition is false, and in this situation, this condition is true. Let's me to open my PyCharm and start to explain the way of writing an if statement in Python. First, I want to define a variable, for example, v1, and it's 20, or simply I want to have that age and it's equal to 20. For writing the if statement in Python, first I write the word if, okay? Then I should write my condition. My condition is age greater than or equal to 18, or is age less than 13? And then a colon. So it's the if statement. This tells Python to check the condition. What is the condition? Is age less than 13? And from that point, a Python expects you, from this point, a Python expects you to write the body of the if, which means the set of instructions you want to occur if the condition is true. For example, if the age is less than 13, I want to age plus equal 10, print age. If the age is less than 13, I want to add it to 10 and then print the age, or print what's stored in age. And you can see here the result is 13. Well, we call it the code block, or the body of if. Immediately after the colon, Python looks for a code block. It's a code block, okay? A code block is a group of instructions that you want Python to execute only when the condition is true. So if the age is less than 13, I want to perform these instructions, or from this view. If the age is less than 13, the test expression is that is age less than 13? If it is, perform the body of if, and it's the body of if. Add 10 to age and print the age. A code block is a group of instructions that you want Python to execute only when the condition is true. In Python, it's important to notice that in Python, code blocks aren't surrounded by curly braces like this. I don't write the body of my if statement in the curly braces. It's not Pythonic way, okay? In some programming languages like C, we write the body of our if statement or for statement inside curly braces, okay? Instead, Python relies on something's named indentation. It's indentation. All lies. What's indentation? Indentation are a certain number of spaces at the beginning of the line. It means instead of starting to write my program from this point, I put some spaces, some fixed number spaces from the first of this line, and separate it, and I write print from this point. Okay. If your code has inconsistent indentation, Python will raise an indentation error because it can't tell which lines belong together. What's I mean? For example, I put this print. I want if age is less than 13, add 10 to age and print the age. I tell you that in Python there is no curly braces for defining the body of if statement, and we use indentation, which are a fixed number of spaces from this point, from the first of the line. And all the instructions that I want to perform if this statement is true should start from this point and should have consistent number of spaces. But if I don't follow these rules in Python, for example, I write age here, age plus equal 10 here, and then I write print age here. See what's happened here? Let me show you. You see here indentation error, unexpected indent. Okay. However, if I add just one space or two space, I again take this exception. Indentation error, unexpected indent. Okay, so the body of the if should have the same indentation or same number of spaces from the first of a line. Let me show you another incorrect example. In this example, because the age plus equal to 10 is not followed with an indentation. Let me write it. We have this error. Indentation error is also an indentation error, but expected an indented block after if statement on line 2. Okay, so after if the Python expect a block of code or a code block, and a code block is defined with an indentation. Suppose that I want to print the age if the age is less than 13. Okay. In this situation, it works. The age is 10, it's less than 13, and I print the age. But if I change the amount of age to 14 and run it again, the 14 is also printed on the screen, but I don't want it. Why this happened? Because I don't follow the indentation rule in Python, and this line, this statement should be in the code block of this if statement. So after writing an if statement, if we don't provide any instruction inside its block, Python will give us a syntax error or an indentation error. Every block must have at least one statement inside. If you need an empty block for some reason, you can use the pass statement as a placeholder so Python doesn't complain. It means write just pass. If you want an empty code block, okay, it's okay. In Python, it's okay. Let's continue. Sometimes in programming, you don't just want to do something when a condition is true. You also want to handle the case when it's not true. This is exactly where the else statements come in, as you can see in this screen. When you use else alongside if, you're telling Python if the condition is true, do the first set of steps. Here, for example, print you're an adult. The else block gives you a way to define what should happen when your if condition does not hold. Here I want to print you're underage, for example, for voting or something else, or you're a minor. Unlike if, the else statement doesn't have its own condition. It simply acts as a default pass. Python automatically runs the block under else whenever the if part fails. This helps you write clear and more complete logic because you can always cover both possible outcomes. So, how we write it? After defining your code block for your if statement, here for example I write print okay, now an else always comes right after its corresponding if block. It's the if block, and its corresponding if block is here. Okay, it begins with the keyword else. I write it followed by a colon. After this colon, Python expects for code block, and you should write something here. For example, it suggests that print you are over 13, and it's okay, it's good. So here, if the age is less than 13, Python prints you are under 13. But if the condition is not met, Python skips the if block entirely and instead execute the code inside the else block, printing you are over 13, for example. Okay, the use of else make our program more robust by ensuring some code will run regardless of whether the condition is true or false, which is especially important for handling situations where input or data might not fit your first scenario. Using else also helps keep our code organized and easy to read because all possible outcomes are clearly shown. However, you should remember that you can only have one else for each if statement. I couldn't have two else here. Blah blah blah. Look here, I have a syntax or invalid syntax. Why I have this? Because each if could have only one else, and just like with if, the code block under else also requires proper indentation. It means if I don't follow the rule of indentation here for this else, I have an indentation error, as you see, or if I put part of this else statement here and part of it with more than, for example, 4 spaces with 6 spaces here, as you can see, I take, or I have an indentation or unexpected indent. I should follow the rule of indentation here. Okay. Let's continue. In many situations, excuse me. In many situations, you might have more than 2 possibilities to consider, not just a simple yes or no, true or false. Okay, this is where the elif statement comes, as you can see here in this slide. The word elif is short for else if. It allows you to check multiple different conditions in sequence and choose which block of code to run based on which condition is true first. It's important, the first. When writing an if, elif, else structure, you can see it here. I have an if, elif, else structure. Python checks each condition in order from the top to the bottom. From the top to the bottom. First, it evaluates the if condition. For example, here the score is equal to 75. First, it checks the if condition. Is 75 greater than or equal to 19? No, it's not. Okay, so here if fails. Now Python moves to the first elif condition. Here, it comes here. Is 75 greater than or equal to 18? No, it's not. So it fails, or the value of this statement is false. So I move to the next elif statement, which is the score greater than or equal to 17? Yes, it is. Okay, I find it, and it's print the grade C on the screen for the user. However, if the amount of age was 15, and if none of the condition here, this condition, this condition, this condition, and if none of these conditions are true, then the else block, here is the else block. Here the else block, it's important to know that else block, you can have else block or not, and it's dependent on your program and dependent on your logic for your programming. However, if you have else, it runs as a last resort if none of these conditions were true. It's important to note that in an if, elif, else chain, only the first condition that is true will run. As soon as Python finds a true condition, it executes the block and skips all the remaining elif and else blocks, even if other conditions would be true as well. Okay? Let's add some if elif here. If age is less than 13, print you are under 13. Elif, I begin with this keyword in Python, elif, and after this elif, you should have some condition and add some condition. If age is greater than 14, print you are over 14, and else if the age is not less than 13 or or if the age is not greater than 14, you are over 13, and under 14. It's my message which I want to print on the screen for the user. I can have another number of elif. Just remember that you should follow the rule of indentation, and the elif comes in the corresponding block of the if statement. The usage of else here is optional, and you can have it or not. It's not necessary for Python. Let me give you another example. Here I want to change the amount of age to 5. If age is greater than 5, print greater than 5, and if age is greater than 0, print greater than 0, and I want to have an else. Here I have an else, and else has no condition. It's important to remember it. Print 0 or negative number. Age is an variable. It has amount of, for example, 10. Let's check what's the output. The age is 10, the age is greater than 5, and also it's greater than 0. What's happened here? Let's check the output. It just prints greater than 5, this line. In this case, since the age is 10, the first condition, the if age is greater than 5 is true, so Python prints greater than 5, and it does not check, it's important, it does not check the following elif or else at all. If you change the 10 to 5 here, as you can see, or to 3, and run it again, let's check the output. Now I have greater than 0. What happened here? The first if a statement or the first condition is failed, so Python check the next condition. Is age greater than 0? Yes, it is, so it prints greater than 0, and it's not printed on the screen. And if I change it to negative 3, the first if is failed, the second elif is failed, and so it's print if it's not greater than 5 or it's not greater than 0. So okay, it's it should be a 0 or a negative number, and it's it's printed on the screen, as you can see. The elif statement lets us neatly handle many different logical cases, keeping our code tidy, organized, and easy to read. it also saves you from having to write lots of separate if statement, and ensure that only one block run for each check. Let's continue. We are here, nested condition. However, sometimes we need our program to make decision in several steps, one inside another. This is called nested conditions. It means having one if statement placed one if statement excuse me, having one if statement placed inside another if statement. Nesting allows to check a second condition only if the first one is true. Okay, so if the first condition is true, we go and check the second condition, and it allows to check a second condition only if the first one is true, and letting us to build multi-stage and more precise decision logic. For example, let's think our real life scenario. If it's raining and I have an umbrella, then I will go outside, okay? In programming terms, we first check if it's raining. Only if the answer is yes, do we move to the next question, do I have an umbrella? Okay, so we first check if it's raining, and if it is raining, then I check if I have an umbrella, or do I have an umbrella. Python handle this type of logic naturally, thanks to the nested if statements. Here's how it works. The outer if tests the first condition. If that's true, Python moves inside the code block of the first condition, where we can place our another if, and so on, creating a chain of decision. But how does Python know what belongs to which condition? Let me show it here. I have two variables. Is it rainy? True. Umbrella. True. I write here. What's the problem? Check the problem. Oh, I have a typo. Umbrella. Okay, it's true. I want to check if is it rainy. Please notice here, is it rainy is a Boolean variable, and umbrella is another Boolean variable. So I can have an if statement with a Boolean variable. It's okay. Why? Because the if statement is followed by condition, and every condition has a Boolean value, true or false. Here I want to check the value of this Boolean variable. If is it rainy, print it's rainy. And then I want to place my second if statement inside the first one. Well, where should I write it, it should be inside the first if. I write my second if, or making a chain of if here. If umbrella, it means if I have umbrella, print if I have an umbrella, I want to go outside. I'm going outside or something like this. Okay. However, if I don't have an umbrella, what's happened? Else, if I don't have the umbrella, I write here print I'm staying at home. And what about check notice here this else, the first else is correspond to this if statement, and it comes after this if statement, and they are in the same block of if statement. Okay, however, if it's not rainy, where should I write this else statement? I bring it here, else, and print it's sunny. And if it's sunny, I don't check if I have umbrella or I don't have umbrella. I'm going to outside or I'm staying at home. It's not important. Let's run this program. Is it rain is true, umbrella is true. So the first if is true, and I want to pass it. In the code block or in the statement block of this if statement, I have to print it's rainy on the screen, as you can see. And if I have an umbrella, if it's rainy, it check if I have an umbrella, it prints I'm going outside. However, if it's rainy but I don't have umbrella, it means it has a false value. Let's check what happened. It is rainy and it prints it is rainy on the screen. However, I don't have umbrella, so this if a statement fails and I check the else statement. Here I want to print I'm staying at home on the screen, and it's printed on the screen. And if it's not rainy, it means the value of its rain variable is false. When I run this part of code, it just print it's sunny, even if the amount of variable be true. Why it's happened? Because this if a statement is run or is executed only if this or this outer if a statement is true. And okay, let me continue on your slides. Okay, so how does Python know what belongs to which condition? We check. The answer was the indentation code inside the first if is indented one level, usually 4 spaces or some fixed number of spaces. Code inside the nested or the inner if condition B here, the if condition B, if is indented one more level. Each further decision you nest adds another level of indentation. Consistent indentation is essential. Otherwise, Python gets confused about which block a line belongs to and give an error. Let's look at a practical. I want to have another, let's think I have another if inside this umbrella. If the umbrella is true, is friend available too. I want if it's rainy and I have an umbrella, call my friend to come outside with me. Okay, so in the body of this if, I want to add another if. I should follow the indentation. It's the first level, it's the second level, call Zainab. Zainab is the name of my friend, for example, here. Check it. It's the first level of this if statement. These are the second level of this second if statement, and it is the third level, which is which belongs to the block code of the second if statement. So nesting conditions lets us test a new decision only after a previous condition pass. Each inner block gets one more level of indentation, and all lines inside the same block must line up perfectly. It's important. Well, it was nested condition, and in this slide I want to talk about simplifying nested conditions with logic and with AND operand. When you want to check multiple conditions in Python, you might first write them as nested if statements. You check the first condition, and then inside that block you check the second condition, the third, and so on. For example, imagine this example here. If is it rainy, and if I have an umbrella, and if my friend is available, I have three nested if statements. I write this first if statement for checking the weather, and I check this second if statement for having the umbrella, and I have this third if statement to check if my friend is available or not. But it's a little complicated, and it's hard to follow the program or follow the logic of the program. One way is to write an if to check the is it rainy, umbrella, and is friend available in just one line of code. And here I want to use the AND operand. Instead of having some if, I just want to have only one if, and I check it with using and. If is it rainy, and umbrella, and is friend available. I want to print it's rainy and I'm going outside with Zaina. Okay? This work if our if all of our variables are true. If all of them are true, I can print my message on the screen. While this method works, it can quickly become understand from the user and for the person who see my code for the first time. So, to make our code more clearer and shorter when all the conditions have to be true at the same time, Python let us combine them using the logical operand and it's and. This way, we put all the conditions together within a single if statement. Python will only execute the code block if every condition joined by and is true. So if it's true and it's true and it's true, it run this line of code or this block of codes, block of instructions, and so on. Okay. Using and makes our code not only shorter but also easier for others to understand. Someone reading your code can instantly see all the requirements for the action to be allowed. However, if your logic requires some action after the first check, or you want to separate your checks for clarity or additional logic, nested if statements can still be useful. But usually, if you're simply making sure several conditions are should be true at once, combining them with and in a single if statement is the clearest and cleanest approach. Let's continue. Okay. Here, let's check some exercises and practice the if, elif, and else together. The first exercise is write a program that takes three numbers as input and checks if all three numbers are positive. If they are, display an appropriate message. Otherwise, print at least one of the number is negative or zero. Okay, what should I do? In the step 1, I should ask the user to enter three numbers. Let's me to come here, clear it. Okay, so at first I should take ask my user to give me its three numbers, and then I should store the values from the user into separate variable. In the step 3, I should check if all three numbers are positive. That means each number should be greater than 0. And I can use AND operator, or I can have some nested if a statement. Both of them are true. And in the step 4, if the conditions are true or is true, I should print a message. For example, all of them are positive. And otherwise, print a message like at least one of the number is negative or 0, as the question asks me. First, let's do it together. In the first line, I want to take ask the user to give me its number. I can write here or do it just like it. I have a I write or define a variable named number1 and an input instruction. Give the first number or write the first number. It's my prompt. Here the prompt pops up, as you can see here. Give the first number. I write 12 here, and this input takes the user response as a string. Okay, as the user response is a string, I should convert it to int, and for performing this operation I use the int constructor or float constructor. It's not important here. Here I just want I just use int. Okay, so the value is stored in the variable name 1. I could copy and paste it here for the second and third variable named num2 and num3. I should fix it second and third. Let me stop it. So the first prompt pops up here. Give the first number 12, give the second number -7, and give the third number 0. Okay, I ask the user to give me its number and I take them from the user. Another way of doing this part of code, I mean taking information from the user, I can write it like it: num1, num2, num3, and in the input I write it: give 3 numbers separated with spaces. Let me make them as comments. Let's see what happened here. $12, $34, $56. I have an value error, so it means this part of code is not complete. I should fix it. For fixing this value error, too many values to unpack, I give it a string. Here I give it a string: 12 space 34 space and 56. But I want to assign these numbers to num1, num2, and num3. For doing this, I should use dot split here. Data split gives the list of these numbers as a string. Okay, so I should transform the output of this statement to int. But let me show you. Is it true to do it? Int input gives 0 number split. Let me check with you. Again, I have an error, type error. Int argument must be a string, a byte-like object, or real numbers, or not list. Okay, so I give it a list, and I want this int constructor convert the amount of this list to int, but it's not performable for this function. To do it, I should use the map function, which take the name of a function and a list, and iteratively give the amounts that are reserved or stored in this list to the pass them to the int function and change their type from the string to the integer. Now let me run this part of code. Okay, I see here process finished with exit code 0. It means my program doesn't have any syntax error or value error or type error, and it's okay. So I unpack the three integers into the variable num1, num2, and num3. And when the user, me, here, write 12, 34, and 56, these are reserved in num1, num2, and num3. And for performing it, I can write my program like this or like this. It depends on you, and it's your it's your decision. However, this style is faster and more convenient for both the user and programmer, especially when you need several inputs at once. And also your code become cleaner, just one line for multiple value. Then I should write my if statement. The if statement, let me write it. I want the if if number 1 is greater than 0, if num2 greater than 0, if num3 greater than 0, print all of them are positive. Else some of them are negative, another else for this if statement, print some of them are negative, and here another else I have here, print some of them are negative. What happened here? I write three if they are nested or they are chained. If the first, the second, and the third if statements are true, I print on the screen all of them are positive number. But if the third if is failed, as mentioned here, at least one of the numbers is negative or 0, I print the output here. Excuse me, I see here some fail. Okay, now however, if num2 is not positive, I again should print this message on the screen. But where should I write this else? This else should belong to this part of code or to this block of code, and I write it here, else print some of them are negative. And if the first number or num1 is not greater than 0, I should write again these statements. At least one of the number is negative or 0 here. So let me check the program. Give the first number 12, the second number negative 0, the third number 0. Some of them are negative, and if you want to have more information or you want to give more information to your user, you can write here a more meaningful message. The third number is negative, or the second number is negative, or here the first number is negative. 0, 12, 12. The first number is negative or 0. 19, negative 2, 17. The second number is negative. Okay, it's an style for writing this, but if I don't to give the user more detail about the output of the program, I can write all of these if statement in just one line. If num1 greater than 0 and num2 and num3, num2 greater than 0 and num3 greater than 0, print all of them are positive, and else print some of them are 0 or negative. Check the output. The first number 12, second 0, the third 12. It show the message some of them are 0 or negative, and it's not important that the first number is negative, the second number is negative, or the third number is negative. Some of them are 0 or negative. It's just the output that I want to print on the screen. Okay, so it's the first exercise. Let's check the second exercise together. It's the code for you to check it in your home. The second exercise. Write a program that takes 3 positive numbers and checks whether they can form a triangle or not. So important that I check first the 3 number that user write on the console are positive and they are greater than 0. Then I should check whether they can form a triangle or not. For this part, we have the triangle inequality, which is a fundamental rule in geometry that tells us whether 3 given lengths can be sides of a triangle. The core idea is in any triangle, the sum of the lengths of any 2 sides must be greater than the length of the remaining side. Okay? So let's write the code. At first, I should want the user to give me 3 numbers. in this form or in this form. It's not important. Or the first side, the second side, and the third side. It's not important. But I take the the number for the length of each side of the triangle. After this, I should check if all the sides are positive number, and the program only continues to triangle checking if this is true. Okay, so if these three numbers are all of them positive, check the inequality triangle. It means if num1 plus num2 is greater than num3, and I want all of this part be an statement for checking in my AND. So I put them on the parentheses. And is num2 plus num3 greater than num1? And is num1 plus num3 greater than num2? This line tests the triangle inequality rule, which says for three sides to form a triangle, the sum of any two sides must be greater than the third side. All three conditions must be satisfied for a valid triangle. I print. Yes, it's a triangle. Else. In this else statement, the numbers, all of them are 0, but they cannot form or make a triangle using them. I print no triangle. But if some of these numbers are 0 or are negative number, I want to tell my user that the numbers are wrong. So I write an else. If this statement is failed, I want to print it for my user. Print some numbers are 0 or negative, and it's the prompt that I want to print for my user. Okay, let me check. The first side is 3, the second side is 4, and the third side is 5. Yes, it's a triangle. All of them are positive. Num1 plus num2. 3 and 4 is 7, and 7 is greater than 5. Then num2 and num3. 4 and 5 are 9, and 9 is greater than 0. Greater than 3. And then num1 and num3. 2 and 5 are 8, and 8 is greater than 4. Okay, so it's a triangle. Let's check another one. Zero, 2, 3. It fails. So it prints on the screen for the user that some numbers are 0 or negative, and it doesn't check the inequality of the triangle. Well, it's enough. Let's check your homework. It's better. It's time for the exercises you need to complete. I have selected 3 assignments for you as homework. You have until next week to finish them. The first exercise is that write a program that determines whether 3 positive numbers entered by the user can be the side of a right triangle. And here you should use the Euclidean theorem, I think. I'm not sure, but it means let me excuse me, wait a moment please. Okay, I cannot do it. Well, I write it here. If C is the greatest side of the triangle, C power 2 must be equal to the A power 2 plus B power 2. Write a program that determines whether two positive numbers entered by the user can be the sides of a right triangle. Okay, and it's a right triangle. It's what I mean from the right triangle. Okay, it's here have a 19 degree. Okay. The next exercise is you should ask user to input a single character, and your program should check if the letter is one of the English vowel, I mean A, E, I, O, U. If it is, the program prints that the letter is a vowel. Otherwise, it prints that the letter is it's not a vowel or something like this. This question helps you to practice working with a string and conditional statements in Python. And the third homework, in this exercise, the user enter any string. It can be a word, a phrase, or something like them, or a combination of them. Your program should examine the string to see if at least one English vowel is present regardless of case. If the string contains any vowel, the program displays a message confirming it. If not, it shows that there are no vowel. Okay, thank you very much for joining me and watching this video. If you have any questions, you can ask me on courses or through the Bally Messenger. I wish you all the best and hope you succeed in your studies. Thank you very much.